Hi, everybody, and welcome back to the Circular Statistics lecturing series, Introduction of Probability. So, in this unit, we'll talk about the counting rules. So, from the video number 1, we already covered the rule of the multiplication of the choice. And then, in this video, we're going to talk about the permutations. And the permutation is another way, another counting rules so can help us to count how many total possible ways it can happen. So we're going to cover the general permutation definitions. Then we're going to talk about the circular permutation and the permutation with object are not all distinguished here. Okay, so the first one, this is the one we cover. This one, problem number 1, 2, 3, and the problem 4, 5, 6. Those are the ones we covered in the video number 1 here. So today we're going to talk about the permutations here. And we're going to cover the problem 7a and the 9 and the 10 and the 11s here. Okay. So before we look at the problem, let's take a look. And for each one here, I have a list of kind of the formula for you, but I'd like to talk more about it, and then we'll go to take a look at the problems here, okay? So let's go to the whiteboard. Okay, so the first things here we're going to talk about is the permutations here, okay? So permutation is the way you arrange the things. And so the permutation, the key things we need to know is for the permutations here, order is matter, okay? That means, that means who would take it first, who would take it second. It doesn't make a difference here. So the permutation is just a way to arrange it. So let's take a look here. So let's take a look at one very simple example. So if I have 3 letters, A, B, C, all right? So I want to arrange these 3 letters. So, and I want to see how many different ways I can arrange it. So I can say, okay, I can do like A, B, C, right? And I can do A, C, B, correct? Then I can also arrange like a B, A, C. I can do B, C, A. All right, then we can do C, A, B, and the C, B, A. So for these 3, that's all the 6 different ways you can arrange it. So that's what we call it is the permutation. So the way we calculate the permutations here, the formula we use, that's what I summarize. So later we'll go back to review that. It's the n to the what? N to the factorial. So like in these examples here, we have 3 letters, right? So n is equal to what? N is equal to 3. So the total way will be the n factorial is a what? It's like 3 factorial. I think you know in the algebra, the factorial is just 1 times 2 times 3, right? So that's why you get 6 ways. Okay, so you get 6 ways to do that. And then the next things here, we talk about the permutation, yes. So the same examples here, right? Same examples here. So I said I have these ones here. This is the example. Okay, so I also have A, B, C, 3 letters. I'm going to pick 2. Okay, so I'm going to pick 2, and in here, the which one is the first one, which one is the second one, order does matter. That means I care which one was picked first, which one was picked second, right? So that's why I said the order does matter here. Okay, so if order does matter, so let's take a look how many ways I can pick. I can pick, first one I can pick A and B, correct? Then I can pick A and C. Or I can pick B and A. So because here we say the order, so which one got to pick first, which one got to pick second, it doesn't matter, right? So that's why we say the A and the B and the A, they are different. That's what we mean the permutation. So it's very important, the order does matter, right? Okay, so now I can pick what? B and the A. Then I can pick the C and the A's, right? No, I can, let me do it more systematically. So I will not kind of screw that up. So B and the A, I can pick a B and the what? B and the C. Now the C and the A, the same way as these two, right? So they have the same elements, but one is picked first, one is picked the second, because we say the order does matter, so those different. So we have the C and the A, and the what? C and the what? C and the B. So we total have how many ways here? We have 6 ways here. So how do I get a 6th way, right? So this is the notation we use here. If you take, so here we call it, this is P, N, R, okay? So this one's the P and R here. So what does the P and R mean? Okay, so this is the formulas here. So this is the N factorial, right? Then this is N minus R factorial. Okay, so that's what is the formula I write there. So now here, let's take a look at these examples here. So this is P, total 3, right? I pick how many? I pick 2. So let's take a look at what is the formula here. So this is 3 factorial. 3 minus 2 is what? It's 1 factorial, right? So this is 3 factorial. This is 1 factorial. So this is what? This is how. This is what we got is 6 here. Okay, so that's the 2 things here. Now let's take a look at example. So this is what we call this the permutations, right? So if you rearrange the whole things, then this formula here is telling you here, if out of N you take R, how many ways you have. And I also want to show you, you can do this from the TI calculator. So let's see, let's take a look, because sometimes, when your permutation is getting big. So let's say that here, let's take a look at these examples here. Okay, so if I want to say 10 to the 4th here. So if I have 10 objects, I take the 4, how do I do that? Okay, so now let me show you how do you use your TI calculator to get the permutations, right? So I stop sharing, and then I'm going to the my TI calculator. So okay, so here, okay, so here, this one's here. Okay, so let's see here, right? So how do let me turn it on, and okay, so here, screenshot and post, okay. Okay, let's take a look at here. So sharing, okay, so, okay, finally it turns on here, right? So we set a 10 to the 4, right? So the way you input, you say 10, all right? And then you do second, let me see here, where is that? You do, you do math, all right? So then you go PRB, right? Then under the PRB, you go N, so you push this ones here, 10 to the 4, then you to the 4 here, then you push enter, right? So it's 5040. So that's a lot easier to use the calculator. So let me switch back to my whiteboards here, right? Okay, so that's how do you use a calculator, and you get this is 5040, right? So remember the permutation, the key part is the order letter. Okay, so now let's take a look at our examples here in the, in these lectures here, right? Okay, so let's take a look at number 7 here. Okay, So the number 7 is telling me, let's say the 4 names are drawing among the 24 members of the club for the official. And then those 4 people, we're going to be president, vice president, treasurer, and the secretary. And we want to see how many ways this can be done, right? So for these ones here, we know this is a permutation problem. The reason why, because, when you choose the 4 people, right, they have different jobs, right? So one of them going to be president. So maybe the first one you choose is the president. The second one you choose is vice president. The third one you choose is treasurer, right? So we do care about the order. So that's why here, the total way you have how many? 24, and you take how many? You take 4 here. So now you can use your calculator and see, you will be able to get the numbers here. So the answers here is 255. 024. So if you just use the calculator, and you can get this, okay? And okay, so now let's take a look at the number 8. Okay, the number 8, we said we have 5 finalists of Miss Universe. So we have Miss Argentina, Belgium, USA, Japan, and Norway. So we want to see how many ways can judge choose. So right now, if I want to choose the winner and the first runner-up, right? So like in this ones here, do I care the order? Of course I care, right? Because the first one could be the winner, the second one be the runner-up. So what is how many ways I can choose here? So this will be P. You'll have 5 finalists. How many I choose? I choose 2. And then you can calculate this one. This will be what? This will be 20. You can either use our definitions or you can use the TI calculator. Okay, so the next one is here. Okay, the next one is here, the winner, the first runner-up, and the second runner-up. So now I'm choosing 3s now. And also, do I care about the order? Yes, because the first one be the winner, second one be the first runner-up, and the third one be the second runner-up. So we do care about the order. So it's the 5. I take how many? I take 3s, right? Okay, so this one's here will give you what? This one will give you 60 different ways here. Okay, now let's take a look at the next things here. The next things here we want to talk about is the circular permutations here. Okay, so I'm going to talk about the circular. The circular permutation. So like take a look for examples here, like the example we have here. If I have A, B, C, D. So if I have A, B, C, D, if I do a lines, right? So I rearrange them so I can have a C, B, D, and I can have a D, C, B, right? And so that means then so like in here, so but what is a circular? Circular that means you put this 4, like A, B, C, D, right? Then you are arranging them in a circle. So I really don't care. It's like who is the first one. In here, I do care who is the first one, right? Who is the second one? Then you rearrange them. So in here, as long as, for example, this one's here, right? A, as long as I care about who is the neighbor, then like they can switch. So if I switch, so like for the circular permutation, if I take turns here, so if I put an A here, D here, right, and the B here, and the C here, these 2, right, so this one's here, this one, and this one, to me, I would treat as the same, right? To me, I was treated as the same. Why? Because for A, they are bounded by B and D, so it's just the whole thing make a terms here, right? So that's why the only thing I care is like, doesn't matter, right? So where the A sit, as long as, the things on the left-hand side or the right-hand side of the A is the same. Then I say, hey, they are the same permutations. So I really don't have 4 different positions to arrange it. So for the circular permutation, what is my formulas here? We'll only have n-1 situations, right? So like in here, if A is sitting here, then I can rearrange BCD. So BCD is 3, right? So it's 4 minus 1. So this says, we say this is the same. So if A is sitting here, it's fine, right? So still is n-1. So for the circular permutation, it is what? It is like n-1. So that's what I put the formula there is n-1 here, all right? So now let's take a look here. So for these problems here, so, okay, I think that is the next one. Okay, so in here we say, how many circular permutations are there for 4 persons to play the bridges here? So we only care, who is on my right-hand side, who is on my left-hand side, right? And I can sit at any side of the tables here, correct? So what is the n-, so what is the formula here? Is n-1 factorial, right? So this is 4 minus 1 factorial. So it's 3 factorial. So it's 6. So I know I have 6 different ways, okay? Right? So that's what we call it the circular permutations here. Then the last one is the one, when you do the permutations here, right? Let's take a look. What is the last one here? I'm try to give you examples here. Okay, so let's take a look at this example. I try to do the permutation. Okay, so instead of ABC, I have AABC, right? I have AABC. So now I will say, okay, so here, in fact, this is the same, right? So, but I want to kind of make underline that. So here, right? So now you will say, okay, so according to, so I can have let's do this. So let's see here, let's do a C. So like if I say here, this is A, B, A, C, right? Okay, so here, this is A, B, A, C, right? So the same way, so, you can do this also. As you can see, they are exactly the same. Like this is A, and this is what? The A is here, right? So when you do that, these two, in fact, is exactly the same, right? Because of you have 2 similar numbers here, so this doesn't matter, right? So I know from the previous definition, I know that overall permutation is n factorials. So that means overall this permutation should be n factorial, so it's 4 factorial. But I have 2, like see here, right? So I have 2, these 2 are similar. Just by itself, how many way the permutations here is 2 factorial permutations, right? But I don't care because they are the same. So that's why, so the answers here, it will be what? Answers here, it will be 2 factorials here, divided because these are the same. I don't need to repeat that, right? Because from permutation point, they're the same, see here. So let me give you another example, see here, and then we can take a look at the example we have. Okay, so I've said, okay, I'm going to rearrange coffee. Right? So I said the coffee here. I'm going to, like rearrange this 6 letters, right? But I know the FF here, they are the same. And what EEs here, they are the same. So if I want to rearrange this letter, so we said here total, I have 6 permutations, right? 6 factorial, because I have 6 letters. But I know the FF, you switch them, you arrange them, they are the same. So how many of them is the FF? Is 2 factorial, right? So the same way is E, coffee, so E and E the same. So they have 2 factorial. So the total permutations here will be 6 factorial divided by 2 factorial, 2 factorials. You get that? Okay. So now let's take a look at our problems here. Okay, so this problems here, they tell you here, how many ways can 2 paintings by Monet and by Renoir and by Degas hang side by side on a museum wall if we do not distinguish between the paintings by the same artist, right? So in here, for these ones here, we know the total is how many? So we have how many is 2 paintings by Monet, and how many 3 paintings by Renoir, and 2 by what? By Degas. So total, I have 7 paintings here, right? But, so the overall, if you have 7 factorial, but your 2 of them is Monet, so they are the same. So you divide it by 2 factorial, and 3 of them by the Renoir, so this is 3, and the 2 of them by Degas, so it's divided by the 2 factorials, right? So now you put it into your calculator, and you can get this is 210. So you have 210 different ways here. Okay. Now, let's take a look at the next ones here. We say how many different ways can 3 copies of one novel and 1 copy of each of the 4 other ones to arrange, right? So I have a total in here, right? So let's say here, this one is have the 3 copies, right? And then the remaining remaining 4, they each one have 1 copy. So here, right? That's what the problem tell you. So let's say now I rearrange it. How many different ways I can rearrange it on the shelf? So total you will see is how many? So it's 7 factorials, right? So it's 3 plus 1 plus 1 plus 1 plus 1 is 7. So overall it's 7 factorial, but which one is the similar ones here? Hey, this one, this 3, I got 3 copies, right? So that's why they are the same. So I divide it 3 factorial. And then the 1, 2, 3, 4, each one is just 1 factorial, 1 factorial, 1 factorial. So 1 factorial, you don't really need to divide it because still is 1s, right? So, okay. So now you put it into your calculator and you will get this is 840 different ways you can rearrange it. Okay. That is about the permutations here. So let me go back to our forms here. Okay, so let's try to review, and that's what we just did. So, this is what we talk about here. We said that the total, the number of the permutations here is n factorials, right? That's n factorial. The number of a permutation, if you have n distinguished number, you take R, is n factorial n minus R. All right, that's what the formula we discussed. And then the next ones here, we talk about the circular, right? The circulars here is n minus 1 factorial. It's because whatever you choose to start, it doesn't matter because it's a circle, right? So it's not in the line. So whatever, you only care your right-hand side, your left-hand side, right? Okay, so this is a permutation. They are not all different. Now what you do, so your total is n factorial, then you divide it by how many similar in each category. Okay, so this is what we call the permutation. In our next lectures, we're going to talk about the combination, and that's another way we are counting. Okay, the permutation, remember the key word is the order matter. That means which one take first, which one take second, we do care, right? Okay, so that's it for this lecture series. We're going to Hope you get a good understanding of this, and looking forward to talk to you in our next lecture series, where we're going to talk about another counting rule for these combinations here. Okay, have a good day, and we'll talk to you later. Okay, bye.